video we will be demonstrating a simple acid-base titration. Initially, it's going to be intended just to demonstrate the proper technique using a burette, as well as a pipet, and the techniques associated with the titration, such as rinsing of the glassware and determination of the endpoint. To start, you'll be helping yourself to a small amount of stock solution from the back of the lab. I've got a big beaker already pre-labeled with its concentration. Of course, that will be in my laboratory notebook. You take a small amount of liquid to perform the required rinse of the burette. The burettes that we use in this laboratory are 50 ml burettes. 0 is marked here, 50 mils is marked there. Any volume dispensed we will do by differences. It has a stopcock. The valve itself is closed in this position and open in this position. It's important that you realize that these are pressure fitted, so that please make sure that the valve as well as the spigot are firmly in place. Now, I'm going to close the valve and rinse with a small amount of sodium hydroxide. Again, numerous small rinses are always much more effective than one large rinse. I'll also ensure that this area gets rinsed as well, so typically just opening it and letting it drain for a few seconds into our waste container is sufficient. For the sake of the demonstration, I'll only do 2 rinses, but 3 rinses is a good idea. Using the burette clamp, ensuring that the burette itself sits in the saddle points of the 2 clamps. It's not uncommon that students will get it a little skewed. It makes it much more difficult to read accurately. The burette should sit comfortably within the indentations of the clamp itself. Again, I'll top up my solution and add 50 mils to my burette. Ensuring that the valve is closed. Funnels aren't generally required for this step, as long as you're careful and keep the end of the beaker pouring spout inside the burette. Spillage is generally minimized or completely eliminated. I will overfill the burette. And what I can do is I can ensure that there's no air trapped in the valve here or in the spigot here. Because again, when we start opening the valve and we're adding material, we want to make sure that it's liquid and not a small pocket of air. That'll throw our values off. So I bring it to the sink or a waste container, open the valve entirely, and give it a small little nudge, and that will dislodge any air that may be trapped inside the valve or here in the spigot. Looking up here, you can see that yes, I've gone below 0. I'm somewhere between 1 and 0 mils. And that's ideal for this lab. Please don't spend any time trying to get the value exact, the meniscus exactly at the 0 mark. We're going to be doing differences. It's much more efficient, better use of time to bring it down just below the 0 mark, read that accurately, and then read your final value after the titration is done. Now my burette is ready to go for the titration. I have to prepare my acid solution. The acid solution we're using today is acetic acid of approximately 0.15 molar. The concentration we are going to determine specifically or exactly through our titration. I take my container, I've labeled it, small amount of acetic acid to rinse my glassware. Pipette gets rinsed. Again, I hold it in the traditional fashion. I'm right-handed, so I will hold the burette with my left hand, 3 fingers and my thumb. Allows me to rotate, and my index finger can operate the top of the pipette. Pipette bulb, and I'm ready to rinse. Again, 3 being the magic number. Small rinse is better than 1 big rinse. Run the liquid into the swelling of the pipette. And again, do that 3 times. For this demonstration, I'll just do it twice, but 3 is always the preferred number of rinses. And again, horizontally, rinsing, oops, there we go, any salts or other solutions from a previous lab. And I can just eject the last little bit of my somewhat impure material. I make the assumption, again, that my pipette and my beaker may have been contaminated initially. That's why we did the rinsing. So I'll throw away, discard the small amount of acetic acid I hadn't used, and get myself some fresh acetic acid from the stock container. Again, making sure you must never pipette out of the stock solution. It's always a secondary beaker. A very firm rule that must be followed. Now, what I'll be doing is I will be transferring 15 mils of acetic acid into our Erlenmeyer flask to perform the titration. Now, we also make the assumption that this perhaps is dirty, though it looks quite clean. I am going to go to the trouble of rinsing it with water to ensure that I haven't inherited any chemicals from the previous lab. And I'm using deionized water. There we go. Good, now onto the 15 mils. Okay. Again, holding it in the standard form, resting on the bottom of the container at a bit of an angle. This will cause a seal between the tip of the pipette and the bottom of the beaker, making it quite difficult to pull a solution up. So again, at a small angle, 20, 30 degrees off the vertical. And up we go. Past the mark, and then my index finger quickly goes on to the top of the pipette. Rotating it gently, I can have very good control of the meniscus, so it just touches the top of the mark. And there we go. Ensure I'm not hanging a drop. Tap it gently against the glassware and let it drain. It's worth mentioning that the pipettes are intended to flow or drain naturally. A small amount of liquid will be left in the pipette tip. That's been calibrated for you. You should leave it there. Don't try to speed the process up by pushing air through it. That'll give you incorrect results. When done properly, the manufacturer tells us that we are dispensing 15.00 mils of solution. Done. I just tap it against the side of the flask, leave it there momentarily, and my dispensing is done. And again, you can see here, we have approximately just a little over a centimeter and a half perhaps. So at this point, I've dispensed exactly, or 15.00 mils of my acid solution into my container. At this point, I'm going to use a small amount of water because there is some acetic acid along the neck of the flask, and when I do the titration, I want to make sure that it's down here in the bulk of the solution. So I just give a small rinse here. I've controlled how much acid I've put in initially with the pipette, so the addition of extra water won't affect our results. It just ensures that our stock solution, or our stock acetic acid solution, is all down here ready to react. We are going to be using phenolphthalein as an indicator. It appears to be clear and colorless under acidic conditions. 2 or 3 drops. 1, 2, 3, 4. There we go. I'll just dry the bottom of the container. And we can see it's a clear colorless solution. Now I'm ready to start adding my base. What's nice about phenolphthalein is it forms a very intense pink color under basic conditions. So I'll be adding base until my solution has its first sign of permanent pink. Now I must record my initial volume of my solution. To do that appropriately or properly, I'll be using a burette reading card. It's just a dark black line with a white background. I hold it behind the meniscus, not to obscure the meniscus, but just below the meniscus. With the white background and the dark tape below it, it actually works as a bit of a lens and sharpens the bottom of the burette or the bottom of the meniscus quite completely. Reading. Point 0.63 milliliters. So I'll write that down, put that into my notebook, and continue with the titration. Now everybody does this next step a little differently. I prefer to use my right hand to swirl the flask and my left hand to use the valve. I hold it, this is the traditional way to do it. My hand may get in the way and obscure it a little bit, but I plan to swirl the solution while working the valve with the left hand. So we've changed camera angles so that so my hand's not obscuring the actual endpoint. So we're ready to go with the titration. We've recorded the initial volume of base. I've added my indicator. I've added my 15 mils of acetic acid. I ensure that the tip of the burette is inside my container. I start adding the solution. Now I have a general idea of the concentration of the acetic acid, and I've done the calculations, and I expect to have to add somewhere between 25, 26, 27 mils of solution. So initially I can add quite a bit quite quickly, and I'll turn the volume down, or I'll slow down the rate of addition when I get a little closer to my expected endpoint. Now we might be able to see shortly a little bit of transient pink color show up as the solution becomes more and more, or less acidic and a bit more basic. There we go, you can see. I'm just going to add a small amount so you can see what I'm talking about. I don't know if the camera picked up on the subtlety a few seconds ago, but I'm just going to add a little bit of base without mixing. And you can see some pink color forming. What that tells us is that small pocket of solution is actually basic. It hasn't mixed with the entire bulk of the acid, so it is still basic temporarily, but that's the pink color we're going to be looking for. And with a little bit of gentle swirling, that pink color disappears. So it tells us we're approaching our endpoint. We're certainly not there yet. It's still a clear colorless solution, but our intent is to go to the first sign of permanent pink color. So it means relatively careful addition of material from here on in. The more permanent the pink color is, and the more persistent it is with stirring, that tells me I'm getting closer and closer to the endpoint. Now I do expect it to reach the endpoint around 26 mils. Right now we have added a total of 20 mils. So I have about another 5 to 6 milliliters of solution. So I'm going to slow down the addition rate. Just double check my volume to make sure I'm not getting too close. So I'm at about 23.5 mils at this point. I don't think I'm quite there yet. The color disappeared quite quickly on stirring. But again, so now I'm adding it at about a drop every 2 seconds. So it's adding maybe a little slower than that. I'll just try and drop. There we go. Drop. Because really, I want to make sure that I add the exact amount. So it'll be colorless. I'll add one more drop, and then the pink color stays. So I don't know if the camera can pick it up. I am adding a drop about every 4 or 5 seconds. I don't want to rush it. This is where the accuracy comes into the experiment. And you can see with each addition, the color lasts just a little bit longer. I think I'm getting very, very close. Okay. I do think I'm probably 2 or 3 drops away. What I want to do now is, just before I reach the end point, you might be able to see that there's some solution here. I don't know if that's base that I've added, or if that was some of the acetic acid splashed up on the flask with my swirling. So what I'm going to do is I'm just going to use a little bit of deionized water and rinse the side of the flask to ensure that any of the reagent that I've added has had a chance to mix in the bottom of the flask. So, still not at the end point, but I think I'm very close. Hopefully with a bit of luck we get this one bang on. But again, I'm looking for the addition of 1 drop, colorless, 1 more drop, permanent pink, and I'm done. Yeah, there was 2 drops. And you can see that it's just starting to change. So I think I'm actually almost bang on. I think I'm probably a half a drop and I'm there. I don't know if the camera picks up that subtle color change, but with this next drop, I think it should be quite obvious. There. So we've gone from a colorless solution, we added a single drop to a permanent pink color, albeit a faint pink, but that is arguably a permanent color change. So my final volume here is going to be 26.04 milliliters. I'm going to record that in my notebook, and I should be able to use that to calculate the concentration of my unknown acetic acid by understanding exactly the volume of this known concentration of sodium hydroxide which I added.